Today we're going to be moving to Unit 5 and looking at Lesson 1 on linear approximation. The big idea here is we're going to use derivatives to determine the effect of a small change. Ultimately, we've already done problems algebraically just like we've done. The math of the problems we're attempting are exactly the same as Unit 4, Lesson 4, Parts 1 and 2. However, what is different is you're going to have to read the problems carefully in order to determine the variables that you need to use and when to use just the geometric equation versus the derivative of the geometric equation. We're going to skip ahead and look at example 3 to start today. All right. Take a moment to read the problem. As I read the problem, the first thing I see is that I have a cable with L6. Okay. So here's my variable L. It has a temperature of 70 degrees. Okay. We are asked to estimate the change in length. So to me, change in length can be written two different ways. We can call it delta L, or we can call it L prime. This is what we are ultimately solving for, L prime. The problem entails us finding L prime. We're also told that the temperature rises to 75 degrees. Okay? So I have a T initial, T at time 0, which is 70. I have a T at time 1, which is 75, which means my delta T is equal to plus 5, the change in temperature. Delta T is also known as T prime. So now I have a second variable defined, T prime. We also are given an equation in its derivative form already. dL, which stands for change in L, over change in T is equal to K times L. We also are told that K is equal to 9.6 times 10 to the negative 6. Since I already have my derivative, I can rewrite this. dL is equal to K times L times dt. Using the notation that we used in the previous unit, L prime is equal to K times L times T prime. We're asked to find L prime, so that's what we're solving for. K is going to be 9.6 times 10 to the negative 6. L is 6, and T prime is 5. Remember, this is the change in temperature. If I put this into my calculator, L prime is going to equal 2.88 times 10 to the negative 4. And in this case, the units are inches because we're talking about a change in length. The next problem we want to look at is example 4. I like example 4 because it makes you really think about what you were given, what you need, and whether you need to work in the derivative or whether you need to work in the original geometric formula. In Google Classroom, I have posted a list of the formulas for you to access and use. Okay, so this is what it looks like. General, right, pretty helpful. In this case, read it to yourself. Pizzas are circular with a diameter of 18. Diameters don't help us when we're dealing with circles, so maybe right from the beginning, we can convert this into r is equal to 9. Okay. Part A of the problem, they just want to know what is the area of the pizza. So for part A, area equals pi r squared. Area is going to equal pi times 9 squared. 81 pi is the exact answer. Or we can estimate it and round and say that it's 254.47 inches squared. Okay? Straightforward, use the geometry formula, no calculus needed. But then when we move to part B, estimate the amount of pizza lost or gained. Okay? This piece here means that translates to we're looking for A prime. How much does the pizza change in area? If the diameter of the pizza changes by 0.4, well, if the diameter changes by 0.4, then we need to also remember that the derivative for area is going to involve r and r prime. So in this case, my r prime, how much the radius is changing, isn't 0.4, it's 0.2. Okay? So when we go to part B, which I'm going to write over here, area equals pi r squared is the geometric formula. But we're talking about the change in variables, so I'm going to have to switch this to A prime. And then I'm going to fill in. Now, if you put this into the calculator, you're going to get 3.6 pi. But remember when it says that the error is at most 0.4, that means the diameter could be larger by 0.4 or smaller. So that translates mathematically to the fact that we could have plus or minus an increase in area or decrease. If I estimate this with a decimal, I get plus or minus 11.31 inches squared. When we think about this in the real world, it means that whoever's making the pizza, depending how big they make the pizza itself, you could have up to 11 square inches more pizza to actually eat.